Hi guys, it's Mrs. Lau. This week we are learning about the three methods of heat transfer. So convection, conduction, and radiation. And so we're going to use these three different types of heat transfer and harness the power of those in a design challenge that you'll have this week. So the first type of heat transfer I'm going to talk about is conduction. And this is the method of heat transfer that happens when substances, like usually a solid, is involved in some way. They're in direct contact with other substances. And so the way that happens is the molecules in those solids, as they start to heat up, they vibrate faster and they bump into each other more. And as they bump into other molecules in the substance, the heat is passed from one molecule to the next. So what I'm talking about with the passing of molecules, here's a model of how solids will behave. So you can see that the molecules in the solids are really tightly packed. They might have a little bit of room to wiggle, and that causes those vibrations. And the faster the vibrations, the more heat that substance has. The slower the vibrations, the less heat or thermal energy that substance has. And you can see those two highlighted molecules, they're locked in place. They're not moving around. They are locked in place. And that's what makes a solid a solid. So as those molecules are vibrating, they can pass the heat energy from one to the next, to the next, to the next. This is a simulation of what happens of how conduction works. And so here we have a heater. It's 50 degrees Celsius. It's about 120 degrees Fahrenheit. And you can see that the heat is starting to spread across this little bridge here. It could be a piece of metal. This could be anything. It's a solid. And it's passing over here to this cooler side, which is also a solid. And you can see that the temperature is rising. And it's eventually going to get to where it's pretty close to the same temperature that's on the left. And that's what conduction is. And so what would be happening if we could see the molecules in this bridge, we would see that they would start vibrating and passing that energy along this bridge and then sending it over to the right side and heating up the right side. So in everyday life, what does this look like in everyday life? So in everyday life, if you've ever made a bowl of soup and you stuck your spoon in your soup and you carried it over to the table to sit down and eat, and then you try to take a bite of the soup and the spoon was really hot. This hot soup passed its thermal energy along the spoon, and it passed into that spoon, and that spoon became hotter. This next video, this is of a conduction wheel, and it has 5 different metals, aluminum, brass, silver, nickel, and copper. And so the way it works is you put the brass center of the wheel, the center of the wheel goes right above a flame, an open flame or a heat source. And what's happening is that it's passing that heat is conducting down the metal spokes of this conduction wheel. And at the tip of each of the spokes, there are little bits of wax. And as this conduction wheel heats up, the wax starts to melt. And so here is the brass. You can see that it's already melted because it's a clear liquid now in that little nook where the wax was. So here you can see the wax is kind of a white color. So the brass melted really, really fast, and the aluminum melted pretty fast too, and the copper. But silver and nickel tended to melt a little bit more slowly. So metals are excellent conductors of heat energy, and some work a little faster than others. The second type of heat transfer is convection. And so this is the method of heat transfer due to a difference in densities between fluids. Super sciencey way of saying that this is a transfer that happens usually with liquids and gases. As things heat up, the space between the molecules gets wider, farther apart, and so it's less dense. And if you've ever heard that heat rises, the reason it rises is because of the space increase between molecules. And so here we have, this is what molecules might look like in a liquid. And so you can see that they're further apart, and you can see that the atoms are more free to move. And that's what gives liquid its kind of flowy, fluidy feeling to it, why it can be poured easily. The next video is a video of gases. And so you can see with a gas that the molecules are really spread out and they're going to move very rapidly. They have all kinds of room to move and they move all over the place. So the hotter a substance gets, the more space there is between the different types of atoms. So hot liquid is less dense. There's more space between the molecules in warmer liquid than it is in colder liquid. Same thing for warmer gas versus cooler gas. Here's what it would look like with a computer doing this. So here we have a heater. Again, it's 50 degrees Celsius, so a little 122 degrees Fahrenheit. And here's a solid heating up, but here it is in a liquid. And you can see that the liquid kind of does this swirly, mesmerizing action here. That's because as the heat, this water down here is a lot less dense than the water at the top. So the water that's less dense is getting pushed to the top and it cools down and it's going to sink back down to the bottom where it gets heated back up again and gets pushed up to the top, floats to the top, since it's less dense than the cooler water, which is represented by the blue colors. In real life, this could look like two different things. This is a fancy way that we would maybe do this in the classroom. This is called a convection box. And so the smoke goes down one chimney. There's a little light here, and it's heating up the air right above this little candle. The air is cooler on this side, and it is warmer on the other side. So the smoke gets pulled in, it travels across the box, and it goes back out the top chimney, the other chimney, because it's less dense. You can't really see the smoke as well. This video, though, you might be familiar with this kind of view. This is a pot of water on the stove, and here you can see the swirling water as it moves towards the center of the pot. It's going to rise up to the top of the surface of the water, cool down and come back down the sides, and then flow and convect. So convection, we have kind of this circulation of fluids. It could be a liquid or a gas. So you can see the convection currents right there flowing along the bottom of the pot of hot water. And then the third method is radiation. And this is the method of heat transfer that occurs across a distance. So substances are not in contact with each other. And this is most commonly, this is modeled by, here we got some sun shining on the ground. And you can see the sunlight or the big squiggly lines. So these things here that look like fuzzy caterpillars, those represent sunlight. So as the sunlight hits the ground, some of the sunlight gets reflected back and as light, and that's why we can see things. But this looser line here, this is called infrared. That is the heat that we feel from the sun. So some of the light is reflected back where we can see things, but some is reflected back in something called infrared. And you can see I've sped up the simulation. The temperature is rising on the ground. You can see that the molecules are starting to move faster. They're passing that energy back and forth, and they're releasing more heat. But the sun is not in direct contact with the ground in order for that to happen. It's being passed through radiation. This is a cool little device called a radiometer. I kept it under a towel. So when it's in the shade, it's kind of spinning slowly there. And it's like a little propeller inside. On one side of the paddles, it has black paper, and on the other side it has white paper, and it works kind of like a little propeller. But when I put it into the full sun, you're going to notice, watch what happens as it's getting radiation from the sun. It starts to spin much more quickly. It's spinning faster and faster and faster. So that's from the radiation of the sun. And if I were to cover it up, it would take a few minutes, but it would start to slow down again. You probably have experienced radiation in like sitting around a campfire or the fireplace. You can feel the heat coming off of the fire. That's an example of radiation. It's passing through space. You're not actually touching the fire, but you can feel the energy, the heat energy coming off of that fire and warming you up. So what you're going to be doing this week is a solar oven challenge. And your challenge is to build a solar oven with items that you have around your house and harness all three thermal energy transfer methods: conduction, convection, and radiation, and use them and harness that energy to make something melty and delicious. Be sure to check out the videos that are in your agenda document, because there are a lot of really good ideas of how to get started and what a solar oven looks like and how that works. That's the second video you need to watch before our Zoom meeting. And be prepared to talk about convection, conduction, and radiation with your science teacher and ask questions about this challenge when we meet in person.